Welcome to Ask and Learn.
Let's find the absolute minimum and absolute maximum values of the function f of t equals t squared minus 4 value to the third on the interval -2, 3. So first we know this function is a polynomial function on t of degree 6, and for that reason it's a continuous function everywhere in the real numbers, but in particular it's continuous on the interval -2, 3. And because it's continuous and a closed interval, we know it has or attain its extreme values on that interval. That is, there are points where the images at those points equal the extreme values. But we also know that the extreme values are attained either on the endpoints of the interval or at critical numbers. So we start by calculating the first derivative of t of f meant, and this is 3 times t squared minus 4 squared times the derivative of t squared minus 4 with respect to t is 2t. So this is 6t times t squared minus 4 squared. As we can see that f derivative exists for every t in the interval -2, 3. Because it's a polynomial function again, and because of that, because this derivative exists at every point, we can say that the only critical numbers of this function are the two values of t for which the first derivative equals 0. So we can write that the only critical numbers of f are those values of t for which first derivative of f at t is equal to 0. So we gotta start with that equation, first derivative of f at t equals 0, and this is equivalent to the equation 6t times t squared minus 4 squared equals 0, because this is the formula for the first derivative of f. And we can factor out this base t squared minus 4 as t plus 2 times t minus 2, and that it is squared, and that is equal to 0. And so this is the same as saying 6t times t plus 2 squared times t minus 2 squared equals 0. And now this is completely factored out, so we can say that t can be 0 or t equal 2 or t equal -2. So these are the three critical numbers of f, and they all lie in the interval -2, 3. In fact, -2 is the endpoint of the interval, the left endpoint. So we got to evaluate the function at these three critical numbers. In fact, in these 2, 0 and 2, because at -2 we have to evaluate it as an endpoint of the interval. So there are 1, 2, 3, 4 evaluations. And we get f at -2 is equal to, the function is t squared minus 4 cubed. So it's -2 squared minus 4 cubed, and that is equal to 0. We have also f at 3, which is the right endpoint, is 3 squared minus 4 cubed, and that gives us 125. Then f at the critical number 0 is 0 squared minus 4 cubed is negative 4 cubed is negative 64, and f at the critical number 2 is 2 squared minus 4 cubed is 0. So from these four values, we can see that the largest value is 125 at 3, and that's the absolute maximum of the function on the interval negative to 3, and the lowest value is negative 64 at the critical number 0. So we can say that the absolute minimum value of f on the interval negative to 3 is negative 64, I would say here, which occurs at 0, which is, as we saw here, a critical number of f. At the critical number x equal 2. We also have the absolute maximum of f on negative 2, 3 is 125, which occurs at 3, which is the right endpoint of the interval. And this is the answer to the problem here. And in summary, we did the following steps. First, we ensure us that we have a function with extreme values attained in the interval, and that's true because the function is continuous on a closed interval, so it attains its extreme values. And we know those extreme values are attained at either the endpoints of the interval or at critical nodes or critical numbers. So we find the derivative of the function, and because that derivative exists for every argument t, then we know that the only critical numbers of the function are those values of the parameter t for which the first derivative is 0. So we state that equation, first derivative of t equals 0, and we found three values. In fact, one of those critical numbers is exactly the same as the left endpoint of the interval. So we got to evaluate the function at those critical numbers and at the endpoints. In fact, there are 4 evaluations because what we said, that is, one critical point is equal to the left endpoint. When we evaluate, we found the largest value of the function was 125 at 3, that is at the right endpoint, and the lowest value was negative 64 at the critical number 0. So 125 is the absolute maximum value of the function attained at the right endpoint 3, and negative 64 is the absolute minimum value of the function attained at the critical number 0. And here I have to repair the fact that here, let's get rid of this a moment, here is t, because it's the variable we were using in this problem. So here is t equal to 8, and here is t equal to 3. That's it. And this is, as I said, the final solution to this problem.